Welcome back. I'm super excited because now we are going to learn Smali, and we do this by hacking this mobile app game, the Space Ping application. Before, we are going to create little pieces of Android applications that serve a special task. For example, that helps us learning what are registers, what are type definitions, what values are in there, how does a function call look like, what are those parameters, return values and objects. So this is a little bit overwhelming if we do this all at once. Therefore, we do this step by step, creating our own Android applications that are pretty simple and basic and where we know what the source code is like, and then we will figure out how the Smali code looks like. We are not going to start with a Hello World application because I never did understand the reason about an Hello World application. Most of the time there's already some stuff included there. We've got a string which consists of chars, which is an array. We've got a function call, parameters and things like this. We start with a little basic program that only consists one integer value, and this value is responsible for the player power. Then we figure out how all the stuff looks like, and in the next step we try to adjust this value to increase or decrease this player power. Alright, let's go. Let's switch to our Ubuntu VM and we are going to create our first Android application. Alright, here we are now at our Ubuntu VM. Let's write our first Android application. So we go into Tools, Android Studio, bin, and then we've got this studio.sh script, and we simply run this. And here we've got the entry point of the Android Studio. So don't worry, you do not need to know anything about Android app development. We are not going to write fancy, animated, complex layouted applications. We are just simply putting our Java code into this application and hit the compile button. That's all. Okay, let's create a new project. Here we've got our first overwhelming window. What do we have to choose right here? Well, we use the empty activity. We know what an activity is. It's simply a screen content. And you can select here between different screen contents. For example, if you want to have Google Maps included or a full screen activity or things like this. But all the other activities make this layout or the code more complex. Therefore, we stick to the empty activity. We can also choose no activity, but then we do not have this graphical output. So we stick to empty activity. That's good to go. Now we have to name our application, and I named this Smali1. Here we can see this package name. It's going to be automatically adjusted. Within language, we stay to Java and not Kotlin. Java is way more easier to handle this. And this one is important, minimum SDK. This means how backwards compatible your application should be. In our case, I guess our virtual machine is running Android 9 or 10, so we would have at least chosen this one. In my case, I choose back to Marshmallow, Android 6. You can also go further back. So for example, 4.4 is also no problem. Or 2.3 is not included right here, but 4.4 is working. By the way, if you're using your own device, then please make sure that you include at least your version of your own device over there. Otherwise, this application might not run on this device. Okay, then we hit the finish button. Now we get the main layout, and this might take a while. We can observe this at the bottom. Now it's indexing. Afterwards, there's a Gradle build happening, and yeah, we will come back after all the things has been finished. What do we have right here? Well, this is our famous Hello World application that is overwhelming, complex, and we do not understand anything about this, and we also do not have to do this. But nevertheless, I give you a short introduction. So here we have our main activity, and this activity extends this activity class. We do not care about this one. Then we've got this onCreate method, and this one is important because an activity has a kind of life cycle. So if you put your application in the background, then there's this onPause method that gets called. And if you get back your activity to the foreground, then there's this onResume method called in this activity stack. In our case, we've got this onCreate method, and this means if the application is going to be created, this method is going to be called. And this is definitely the case if we start this application and this activity appears on the screen. Therefore, we can treat this as our main function. So do not care about this onCreate and override stuff over there. We will take a look into this later on. Not in this chapter, but within the runtime analysis where we take a look at the activity stack. But for now on, let's just say this is our main function. And we do not care about this one, and also the parameter over there. We just put into our code over here if we want to run this code. Okay, that's all we need to know. On the left, we've got the structure of this application. So we've got the Android manifest XML, this one. And if you take a look into this, we can see, okay, no permissions. We can see our activity, this main activity over here, and we can see this well-known intent filter, which means this is our launcher activity. This is our entry point of this application. All right. Then we've got this resource directory over here. We are also pretty familiar with this one. And here, by the way, is this values directory that contains, for example, those colors which are regarding to our theme we are using. And those values gets compiled into this resources.arsc. Just here to wrap this up from the Android structure part. Okay, we also do not care about this one. We could now build and run this application because this is an application that's already finished. We can now simply hit the build button and we can create our first application without inserting any line of code, because this is our blueprint of our Android application. To do this, we could say build bundle, build APK. And this might take a while on the first time, because then all those things get compiled into this APK. And if we make a modification, then the compiler relies on some cache, and this will be a lot faster. In my case, I've got this now over here, build APK generated successful. And if I click locate, we've got our first build over here. So we have built an APK without doing anything, which is super great, right? Okay, so now let's go back to our real approach. We want to learn Smali, and therefore we have to do this step by step. And we start with our own hello world program, which is an integer value. Okay, let me close this over here. All right. Now we go into this one and we create a new class. This makes this afterwards a little bit easier. We name this class, for example, player. And here we define a new value. We say int power equals 10. All right, that's all. We do nothing more. We just do this one. Now we hit build, make project. Gradle build is running. Okay, looks fine. Now we hit build bundles, build APK. You can always hit build bundle APK directly. You do not have to use make project first. Okay, now we go into this location, and here we have our APK. Let's go with the Smali approach. To get these Smali classes, we have to decompile this application, and we use the APK tool for this. So we stay in the same directory, right click, open a new terminal, and then we say APK tool, d app debug APK. This has been finished. We go into app debug, and now we've got the Smali directory. Let's have a look into this now more in detail. We've got Android, Android X, and COM. These two are regarding to the Android application build system itself. So if we go back, we cannot see them over here, and also not there, but these gets compiled into this application based on, But these get compiled into this application based on the things we are using. For example, we extend a class over here, and therefore we also need the code for this class. We do not care about them. We are just interested in the package com, app hacking, Smali, and then the player class. Let's see. We've got this directory com, and this one contains now app hacking and Google. So we stick to app hacking, Smali1, and here we have now all those Smali classes. Let's see if we can see our player class. Here's our player class over here. Nice. Let's open this file and have a look into our Hello World Smali exercise over there. Okay, you can choose between the code editor, gedit, or Vim. In my case, I'm using the code editor. So we can simply drag and drop this over here, I guess. Yes. And there's no Smali highlight over there, but we can use the Java highlight. That's well enough to get a little bit about this. Okay, before we analyze the Smali code, let me show you some neat tricks over there. So if we go back to the directory, we can also use JADX GUI. and we provide this app debug APK. And if we go into app hacking Smali 1 player, we will find the Smali button underneath this. And if we hit this, we directly compile our code into Smali, so we do not have to use the APK tool to decompile this. But there's a difference. Let me show this to you. Let's put them side by side. So this is regarding to the decompiler, and those are different, and therefore we also get a different bytecode output. Both are, of course, this is regarding to the decompiler. The APK tool is using a different decompiler than JADX, and therefore we also get a different bytecode. Both outputs are of course valid. In my case, I like to stick to the APK tool output because this is a little bit more easier to read. I give you the solution about this one. Register means that the compiler named here that we've got two registers, and we can see them over here. We've got V0 and we also got P0. In this case, it only says we've got one local register, which is V0, and P0 is a parameter, so we provide a parameter at this point. The APK tool makes a difference between local registers and parameter registers, and on the right side, these get matched together under the whole topic registers. This might be a little bit confusing at the beginning. I'm absolutely understanding this, but I just wanted to show you that you get different outputs if you use different tools. We will stick to the APK tool output because this is a little bit more precise regarding to the naming of those. Okay? These outputs are different, but the result is the same. So both apps work in the exact same way. Last but not least, there's also a plugin for the Android Studio itself. So we do not need to compile this application with the Android Studio and decompile it afterwards with the APK tool. We can directly do this within Android Studio. To install this plugin, we go to File, Settings, Plugins, and then please make sure you have selected the marketplace over here. And then we search for Java to Smali, this one. And then we hit Install. Please read carefully through the terms and conditions about this. And if you accept them, we can install it. And we click OK. Okay, now the plugin has been included into this IDE and we can use this. Sometimes you also have to restart Android Studio that this effect takes place. Okay, we click onto our player class over here and then we go to Build. And at the end we have now this button Compile to Smali. Let's hit this. This takes a while. We can observe this at the bottom of this page. And after it's finished, we get a new tab over there. All right, and here we have now the decompiled Smali code out of this Java class. We can see it's also using this approach like JADX does with the register part. So we do not split them up between parameters and local variables. We summarize them and put them into the register word. In my case, I do not like this approach very much because having the ability to separate them between local variables and parameters makes Smali even more easier. Therefore, I like to stick to the APK tool approach. But if you have to do a fast task, then this can come super handy. You can write your code over here and then you can simply hit this button and you directly get out your Smali code over there. Alright, now let's analyze our first output of our Hello World application. So this Smali output right here. We are going to analyze this on the slides. So I take this output, put it on a slide, and then we go through this. Let's switch back and have a look into this. Okay, let's do a quick recap on this. So we've got our application. We did insert a new class and we added this variable named power. We compiled our application and this was our starting point. Afterwards, we did decompile this application with the APK tool. And then we did end up with the Smali structure. And the Smali structure contains single directories, and these single directories are regarding to the package of this class name. So if we compare them against each other, we can see the app hacking Smali 1 is exactly the same package name over there. This is how our Smali structure looks like, and therefore we can find this player.smali class immediately. Okay, this is what we've got. Now let's take an analysis on our Smali code. On the left we've got the player.smali and on the right we've got the player.java. So The player.java looked like this. We've got our class int power. On the left we have the decompiled Smali part. Now let's see what can we understand right now, and I will be absolutely honest with you. If I do mark anything that we do not understand right now, then please drop me a message underneath this box, alright? Okay, what do we have here? Well, let's take a look. Well, okay. No, that's also. Yeah, okay, I've got it. Can you spot this? Can you spot the value 10 maybe on the left side? But maybe if we strongly concentrate ourselves onto the player.java file, maybe we are able to identify the value 10 on the left side. So I give you a moment to think about this. Well, let's see. The value 10, it's definitely not there in this decimal value. Let's think about what we've got on the left side. We've got a bunch of really strange words, we do not understand this, but we've got an 0xa. And 0x, this might be hex, I don't know. Let's see. If we're using a Python shell, we can represent this value 10 in form of an hex value. So we open a new Python terminal and we type in hex 10. And then we get this 0xa. And the 0xa is also on the left side over there. So this might be our value 10. We do not know this right now, but it's pretty likely the case. Alright? Nice. We have understand our first part within Smali. Okay? So this is a huge step. And by having this step, we also can do a lot of stuff right now, even if we do not understand all the rest of this. You will see this in a moment when we do our first exercise. But for now, I would like to finish this video because I do not want to stick that much together in this. We have taken a look on different approaches how we can get the Smali code out of this application. We have seen some really fast techniques, for example JADX GUI, the Smali button, and also if we want to write our own Smali code, we can do this directly in the Android Studio. We write our Java code and then we use the Java to Smali plugin. We've also taken a look into the difference of the decompiler regarding to the Smali output. So we have seen some decompiler summarize those registers to one big blob, and others split them up between parameters and local variables. Then we have analyzed our first Smali code and we realized we cannot understand anything about this, but we might have found the integer value represented in the Smali code. And this is a huge deal. Okay, and this is also the point we stop right now. We do this step by step and we will increase our steppings further and further. For now, that's all. I'm looking forward to see you in the next video.